Hello everyone, this is Easy Automation here, and today let's have a look on the counters in Allen Bradley. As the name suggests, counters means they are counting some kind of quantities or the signals and accumulating the count to show the actual number. The topic is pretty much easy, but if you are not subscribed to Easy Automation, it could get hard to learn it in the first place. Just subscribe and let's begin. In RS Logix 500, there are two types of counters, and you will find them here at timers and counters. And the first one is CTU, which is up counter, and another one is CTD, which is down counter. And as the name suggests, they both work differently. CTU, which will count upwards like positive direction, and CTD, which will count in downward direction, like which will count in minus, like -1, -2, -3. Let's see how it works. To begin with, I will just use one CTU here. I will just add one rung here and I will drag this CTU here, and to address this CTU I will just put C5:0 and I will just give the preset value of 5, and this accumulator will stay 0, and you can use the counter address up to C5:255. Beyond that it is not possible to use the counter. It will show you the error, and this counter will count the high signals. Like whenever the signal is high, the counter will increment the accumulator by 1, and whenever the signal goes low, the accumulator will store the count, and whenever the signal goes high again, then this counter will increment this accumulator by 1, and that's how this counter will count the signals and store the count in accumulator. For giving the signal, I will just use one NO contact here, and I will just use one input address here, which will be our proximity sensor. Whenever the proximity sensor gives the high signal, the counter will increment the accumulator by 1. Let's see how it works. Now our accumulator value is at 0 and our preset value is 5, and whenever the accumulator value and preset value are going to be equal, then our done bit will energize here. Let's see how it works. For that we need to give one high signal from this proximity sensor. Now I am just toggling this signal. Our counter has counted 1 and the value is stored in the accumulator, and whenever the signal goes down, the accumulator will store the count, and whenever the signal goes high again, the accumulator will get incremented by 1, and whenever the signal goes low, the accumulator will store the value, and this is how the counter will count up to 5. Like whenever the signal is high, it will increment the accumulator, and whenever the signal is low, the accumulator will store the previous value. This is how the counter will work. But whenever the accumulator value and preset value gets equal or go beyond the preset value, then our done bit will energize, which can be used in further applications. Like whenever you want a indication after preset value completion, then you can use this done bit for energizing any kind of output like lamp or alarm. We will talk about this done bit in our further lectures, but for now I think you have got the idea how up counter works. And even if the accumulator value is reached the preset value, our counter can still count beyond the preset value. Like whenever I give another high signal from this proximity sensor, the accumulator will count beyond 5 or beyond preset value, like it is 6 now. And if I give the high signal again, then our accumulator value will get incremented and our done bit is still on because the accumulator value is greater than the preset value. This is how CTU works, and this accumulator value can vary from -3 to 768 up to +3 to 767. This was the simple up counter. Now let me show you the down counter. For that we need to go offline, and to add the down counter in the program, you can drag the down counter from here, or you can just change this CTU to CTD, like by typing the CTD here. Both ways you can use the down counter. I will just prefer to type the CTD here, and I will just delete this one, and I will just keep the counter address C5:0, and I will just keep this preset value up to 5 and accumulator value will be 0. Let's download. Now if I give the high signal from this proximity sensor, then our counter will decrement the accumulator value. Like it was 0 before the high signal, and now it has gone to -1, and if the signal goes low, it will store the value -1. And if I give another high signal to our down counter, then our accumulator value will get decremented by 1, like it has gone to -2. And likewise, whenever the signal goes high, the accumulator value will decrement by 1, like -2, -3, -4 up to -3 to 768. This is how the down counter works. And if you are thinking about the done bit, let me show you something. So to energize or turn on this done bit, I need to put here the minus value like -5. And now let's go download this program. Our program is in running condition, and you can see here the done bit is initially high in this down counter, and if I give a high signal from this proximity sensor, then our counter will decrement the accumulator value, and whenever the accumulator value goes beyond -5, the done bit will go to low. Like now the accumulator value and preset value are equal, but our done bit is still high. But if I give another high signal, then our accumulator value will go to -6, then our done bit will go low. So this is how the done bit of down counter works. So I hope you got the point of down counter and up counter. So let me create one simple program in which we can compare the down counter and up counter. So for that we need to go offline. So to create that program, I need to delete this program first. So delete. So I will just add two rungs here, in which I will just add one branch instruction here, and I will use one T-on instruction here. So here in this program, I have created one pulse generator, which will create a 2-second pulse. Like this logic will give us the high pulse after every 2 seconds. And that pulse will be our done bit of our first timer. And I have used that pulse here and here on the NO contact, and that pulse will be counted in up counter and down counter as well. And by this example you can get a clear idea how up counter and down counter works. So let's download. So now our program is in running condition, and our up counter accumulator value is at 0, and our down counter accumulator value is also at 0, and the done bit of our up counter is off and the done bit of our down counter is high. And if I start this pulse generator, the pulse generator will generate a high pulse after every 2 seconds, and that will be counted in up counter and down counter. So let's see how that works. So I will just start the pulse generator. So I will just toggle this start button, and our pulse generator has started generating pulse, and our accumulators are going upward in up counter and downward in down counter. And here you can see the operation of done bits of up counter and down counter. Like whenever the accumulator goes beyond the preset value, the done bit will go high in up counter, and whenever the accumulator value of down counter goes beyond the preset value, then the done bit will go off. So this was a simple example to compare the up counter and down counter. And now you might be thinking how we are going to reset these accumulator values. Like to make this accumulator value 0, we need to reset these. So to reset these counters, we need to use the reset coils. So now I will show you how to use the reset coils. So for that, just go offline. So to reset these counters, we need to use the reset coils, which will be here. So for that, we need to add one rung here, and I will just add one NO contact here, and I will add one reset coil here, and I will just use a branch instruction here, in which I will just put this reset coil, and I will just put one another reset coil here, and I will just extend this branch down and use one unlatch instruction here like this, and I will just give the binary bit address to this NO contact, and I will just use this address for this unlatch instruction. And to reset this up counter, I will simply drag this C5:0 address to our reset coil, and to reset this down counter, I will do the same. Like I will just drag this C5:1 to this reset coil, and now we can reset this up counter and down counter using this memory bit. So let's download. So let's see how these reset coils work. So now I will simply start this pulse generator, and our counters will count the pulses, and by using this memory bit I can reset the accumulator values. So now I will just start this. So now I have started this pulse generator, and our counters are counting these pulses, and if I toggle this memory bit, then our accumulator values will go to 0. So let me just toggle this bit. So I will just toggle this bit like this, and our accumulator values will go to 0 and will start counting again from the 0. Like if the pulse generator was off, then our accumulator values would have gone to 0, but our pulse generator is still on, so that's why the accumulator value will go to 0, but our pulses are still coming, so that's why our accumulator values are storing the new values. The counters are counting those pulses from where I have resetted them. Like let's suppose the counter has counted 100 and I have resetted to 0, and still our pulse generator is on, then it will start from 0, 1, 2, 3, 4 up to 3 to 768. So this was the simple explanation of up counters and down counters in Allen Bradley. So if you have any queries about counters, then feel free to ask in the comment section. I will always be there to answer your questions. And if you learned something new, then hit that like button and subscribe if you are interested in PLC automation. So with that being said, I will see you in the next video. Till then, keep exploring our previous videos. Bye.